Welcome back to Ye Old Foundry, ladies and gentlemen, otherwise known as my garage. Now, I'm sorry that I had such a big gap in between sessions or episodes on this, but before I was able to progress any further, I ordered something so that it would be here when I was working. Okay. And any of you molders that know that have seen this before, you'll know what this is just by glancing at it. It's a pneumatically operated vibrator. And no, not the kind of vibrator some people are thinking of right now. But essentially what it is, it's going to be used in this project to add the vibration needed to make all the molten zinc go all the way to the bottom and not have any air pockets left in there. Usually what we wind up doing, and what we did do almost all the time, is that we would have a big screwdriver, and when somebody was pouring this, they'd be tapping the side of this to try and force any trapped air that might be down in the little valleys and crevices down in here to come up and not be trapped down there by the molten metal folding over it. Okay, and that's what I wanted to do, is I wanted to get this and arrange it so that when this whole affair is in the my vise, that the vise would be vibrating, because it's only on wood, right? So the vise would be vibrating and forcing any air to come up out of the socket, and making certain that we have 99% fill or 100% zinc filled in all those nooks and crannies between the pieces of metal right there. Okay, so what I'm going to do, I just tested the light, and the light appears to be fairly nice out here. I hope you can hear me. I'm going to try and keep my voice up so that you can hear me. Let me get some of this out of the way. Okay, now the idea is that when you open this up, getting it ready for the sockets, that you don't undo any part past the end of the socket. Okay, now I'm marked here for the bottom of the socket, but I don't think I'm right. So what I'm going to do is I'm going to get a marking pen, or just an old Sharpie, and get one of the sockets, bring it over, and we will remark this. We'll be a little more precise on this. Okay, let me I'll go ahead and put you down here. I'm going to take a lot of care, be very, very careful in moving with this. Now, that's about it right there. Okay. Just continue it, mark it all the way around. Alright. Now, why did I put this on here? Well, it's always a good habit to stay in the habit of being, you assume that this this project is going to lift up a nuclear bomb. You don't want nothing to drop from your project. I mean, from you when you applying sockets to a wire rope, you want to do everything perfectly, everything just right. Okay, and one of the things that you don't want to do is you don't want to score these wires. You don't want to make impressions on them. You don't want to hit them with a grinder. You don't want to damage them in any way whatsoever. Okay, but here's the problem: you've got to put seizing wire on this, and you can't do it holding it between your legs or having one hand do it and another. You need both hands to do this. Okay, so you got to put it in a vise. Now, we didn't think much of it back when I was doing this when I was in the Navy. We just plain put it in a vise, okay? And we just tightened it just enough to where it would hold it so that we wouldn't have any problems, right? Well, I am going to be making this for somebody else. I don't want this to be scored up or damaged in any way whatsoever. So this being 3/4 inch cable, I went and put this this PVC pipe over it so that I could put it in the vise, put some good power on it, and this will be held for me. Okay, now it's not going to move. Now let's see if I can put you in a little bit better spot. I'm going to presume, okay, see how this can't be up like this, okay? These ends, they can't be past this point at all. If any, they can be, oh, 1/8 of an inch, 1/16 of an inch below that level. You do want the maximum amount of wire in that you can get, because the more you get in there, the more grip on this wire the zinc will have, okay? So the more grip it has, the stronger it is. The more, likely it is that this isn't going to pull out. If you were just to have, let's say, just that much in there, you're wasting half of it, okay? So you might run into having problems, okay? Now, the first thing, you've got this first one to do. Now there's a couple different ways of doing your seizing. I got seizing wire here. Find the end of it, okay? Now, how much, I may have said this before, and I'm pretty sure I did. How wide a seizing do you do? Well, the instruction says you do it no less than the diameter of the wire of the cable that you're working with. In this case, it's 3/4 inch. The width of that seize will be at least 3/4 inch. It can be a little bit more, okay, but it shouldn't be any less. And I'm going to try and guess how much I actually need. I can always chop some off, or I've got plenty here that I can make another piece if this is too small. Now there's a couple of different ways. I mean, the way we tied this stuff back when I was doing it, all we did is that we had a stem sticking up here. We just wrapped it very tightly, as tightly as we could. And once we got to the point where we were going to run out of a wire, we would just do that, and then we would use the twister, the wire twister, to bring that all the way down. What I found is that this often doesn't really make it as strong as it possibly could. And in one moment, stand by for a second, I've got to get something to measure with, otherwise I'm going to screw this whole thing up. Okay, back. Hey, believe it or not, that's a good width. Double, triple check. It's not really good long enough, but it can be a good training example of what I'm going to show you next. Now, this other way that you can do this, see this end right here, see these crevices in here, these little dips, this isn't solid round, this is solid, but it's not totally round. You have these parts in here that are there because of the forming of this cable. This way of doing it is a little stronger, and it has an advantage. So what you do, you take one end, you lay it in the crevice, right? Then you come up to the place where you're going to start your wraps. You start that. Try to tighten it as good as you can by hand, and then you see how you have that waiting for you right at the end, right? You take your wire twister, twister, yeah. You clamp it. Okay, this is the locking mechanism right here. You clamp it, and then this part, you see this? I'll make sure. You see this? That is twisted right there, okay? And what it's made for is that when you pull on that, it automatically twists for you, okay? And then this is strong. Let's see how wide this is using that. Yep. Okay. You don't need all this extra here. Get your pliers. Snip it. Okay. Then you tap it down, lay it flat, and I can't move it, so that it's out of the way. There ain't nothing more painful than getting your fingers stuck by the end of these wires, okay? So try and lay them flat, try and get them out of the way so you don't get hurt again, all right? Or hurt at all. Now, I don't want all this plastic or vinyl here in the way, so I'm going to pull that out of the way. Now, this is, we're not just putting one of these on here. We need to have a backup. Now, back when I was doing it many years ago, we had 3 of these that we'd put on, okay? We usually I mean, they didn't really tell us a distance so much. What we wound up doing is well, I think maybe they did tell us the distance, but what we did is we went and did the distance as like we were supposed to. But then we found out, hey, this is really only like 2 fingers. Okay, and then we used that, remembered that from that point on, and we still had the same strength, but we didn't have to get out the measuring tape all the time. But in this case, we only have to have 2 of them. And what they said the requirement is that you have the distance between the first and second wrapping is 6 times the diameter of your rope. Okay, that's the requirement in the instruction. Why it's 6 times? Well, there's got to be some empirical evidence that proves that that's the strongest place to put it. Okay, that it does a proper job of backing up this first wrap right here. Okay, now 6 times this the 3/4 inch diameter is 4.5 inches. Okay, now I got to see if we're even got enough room for 4.5 inches, which we don't. So I'm going to have to loosen this a little bit. 4.5 inches is right there. I'll mark it. Okay. Now I'm ready to do that part. I get another length of my seizing wire, and I'm going to duplicate what I did over here. Tighten this down a little bit so things don't move around on me. Yep, it's good. I put the end of this seizing in the gap, and then holding that in place, I start wrapping. Okay, you absolutely try and do it as tight as you can by hand without hitting the camera. Let's see how well I'm doing. Just fine. Okay. Snip the extra off of this. Give it a preliminary twist. And then twist it very nicely. Okay, so what it does, you have this part that's laying in the fold, all right, and it's underneath all this. You twist it, this pulls tight, it pulls this end tight, the other end pulls these tight, and now it's not going to move. Okay, I snip off the extra. Then you tap it down so that you don't accidentally stick your hand. Okay, now here's something else that back in the days that we had to operate with that instruction, they didn't have this proviso. They didn't have this option that you could elect to operate under. They say in the new instruction, in lieu of this seizing wire, you can use these wire clamps or these hose clamps. Okay, now they got to be strong, because what I'm going to do in a little bit, if I don't have something very, very tight, very, very strong here, when I unwrap these, let's make sure I'm got you here. I unwrap these and I unwrap the individual things here. We don't want this, because I am going to pull it up here like that. We don't want this to migrate down and open up a gap here that we don't, we absolutely don't want. Okay. What we wound up doing back when I was doing this is, when we did have this, we had to have this. Okay, let's say an inspector came in and was checking up on us. If he didn't see these, he'd tell us to put them on there. Otherwise, he's going to not cancel the job, but he's going to fail the job, and we didn't want that. So what we wound up doing is, we found that if we were to make sure I've got enough stuff here, if we were to put the hose clamps over this, the wire, seizing wire, that this would make a very good way of making certain that none of this moved. Now, I don't recall putting it directly on top of the seizing wire. I think what I did is I went and put it directly below the seizing wire, so that the seizing wire would still be against the bottom of the socket, but that this, being right next to it, butted up against it, wouldn't allow the seizing wire to move when these pieces were being opened up. Broomed out is the phrase that we used. Broomed out. Okay, this end, it's set up, seizing wire wise, it's set up, it's ready to go. Okay, now I'm going to show you, and once this whole operation gets completed, once the socket is all on here, and the zinc is poured and it's permanently attached to it, well, until in the far future when it's gone bad, these can be taken off, can be removed, so that it's just smooth all the way across. Okay, they say to do, at least this one gets taken off. This one here being right up against it, it's a psychological thing. It's not really going to be any stronger by leaving this there, but it does kind of hide the gaps in here and makes the person who has this think that this is even just a little bit stronger, and that they have more confidence in your cable. Okay, but what happens if you have a cable that you need to have to leave the seizing wire on? It's like a permanent a permanent thing, a permanent installation of the seizing wire. Well, we have another way of doing it, and I showed you one way of doing it. Now here, let me double check on something here. I'm going to get the other socket. Let's check these out. Yep, they're the same. I just wanted to make certain that, despite the fact this is a closed and this is an open socket, that this portion right here was the same on both. And you can see that if they're not the same, they're very, very close. Okay, so now this end, I'm going to do these seizing wire just a little bit different. It's not absolutely necessary unless the instruction calls for it. But let's get this off before I bring these up to, see the ends here? I bring them up to even with the end, not going past it. I mark where the bottom of this socket is going to be, and nobody's messing with it right now, so this isn't going to spring open. Some wires will spring open though. Some of the smaller ones, because they have more tension on them to try and keep them conformed, but they don't have the stiffness of the larger pieces of wire, so they will unravel on you if you're not very careful. In this case though, the 3/4 inch is not going to unravel on you. Okay, now here's the bad news right now. I've made this, or I've allowed this 3/4 inch PVC to be too long for me to show you the other way of doing the seizing wire. So what I'm going to do is I'm going to pause the camera and I'm going to remove a certain portion of this, and then we'll be back. Okay. Okay, this has been shortened now. Let's get you back basically in the angle that we need. This has been shortened now that I can show you how to do this. Now, this is the kind of messy part of it. I'm just going to have to hope that this isn't going to fight me too much. I keep forgetting that I'm trying to talk through plastic case. Alright, number one, I've already marked the bottom of the socket. Okay, now, so that's where the winding starts, right? Now, they didn't say in the instruction exactly how wide this permanent seizing had to be. There was no indication, like so many times, the size of this, or, you know, it didn't say. So what I'm going to do is I'm going to just make it my hand width. Okay, so that's about 5 inches, 4.5, 5 inches. So I'm going to put the end of this seizing wire in a groove. I'm going to follow the groove all the way down, hopefully. Okay, found it. Start my first turn. There we go. And I just keep turning until I get to the width I want it. How wide it needs to be is entirely dependent on you. It can be only 1 inch wide. Or, I mean, you know, this is wide. By that I mean, I have not seen any short permanent ones. They were usually fairly long. Okay, but I didn't see them much bigger than the width of a man's hand. Certainly no longer than 6 inches. But that was, don't forget, it also depends entirely on how big a wire you're trying to seize. The bigger the wire, the more seizing wire you are going to need to wrap it adequately. And it's gonna, hey, yay, it let loose. Okay, I thought it was gonna fight me, and I thought I was gonna have to argue with it, but it was just being bothersome a little bit. Okay, we're getting close. Don't forget, this isn't just for looks. This absolutely is required because you don't want your cable to unwrap any more than you require it. And that's about it. Okay. Snip off the excess. There we go. And here's the part that was lying in the groove. Give yourself a twist, and now it won't unwrap on you. To me, this looks nice because it looks a lot like the wrappings that the bosun mates used to use on not just the life rails, but on ropes. They would have projects. I think they call it no, they did. The stuff they were using was called small stuff. The small twine instead of rope. But the bosun mates used to make a lot of neat looking stuff. Some of it very useful out on deck, some of it attractive, very attractive. And it dressed up a lot of the areas on the ship that could have just looked industrial, but they dressed it up, especially like around the area of the bridge, where the people stood watch and steered the ship, the quarterdeck, where there was people posted there on watch, to control who came on, who went, who left the ship, so forth. This is plenty wide enough. It's 4 inches wide. Okay, so on this one I can be relatively sure that it's not going to drift down on me while I'm trying to open these up. Okay, I think what I'm going to do is I'm going to hold off just a second. I got to go get a screwdriver, and I'll show you why. It helps. And a regular pair of pliers. I'll be right back. Okay, I'm back. Now I couldn't find a regular pair of pliers, but this will do just as well, because we don't care if this end is scratched up at all. Alright, reposition this. Now you see how you have to grip this so that it doesn't move around on you, and I don't want any of this sharp edges to be scoring this up. Okay, so I'm going to re-aim you guys a little bit, tilt you up a little bit, so I can be more or less assured that you're going to be able to see this. Now, first thing, you take something like a screwdriver and you start unwrapping these. And this is pretty stiff material, so you're going to have to bend it down. Okay, let me look at something here. I don't have the same supplies as I would have in the foundry, but I'm going to try and find something. If you can find a piece of tubing, this will help you on this. Okay, I'm going to look around. Oh, wait a minute, I got something that has a hole in it. That'll help. Okay, I really hope you guys are gonna be able to hear me. This is better to do it with tubing because this is kind of a bulky thing. Okay, now when these are made, these wraps right here are wrapped around a core. Okay, the core of the cable. Bend it a little more. That core needs to be cut out. Okay, as far up to the end here as you possibly can get it. Why? Because the core, you will see in a moment, is made up of different pieces of metal, different sizes, and if you leave it in there, when you dip the whole thing in the acid, the core will act as a wick and draw the acid up into the rest of the cable. It is, you know, it's called being wicked up. Acts as a wick. Anybody that's really young, don't know what a wick is, that's part of the, well, you got candles, they got that part in the middle, the cotton, that acts as a wick, or that is the wick in a candle, that when there's molten wax surrounding it, it draws, because of it being made of a cotton material, it draws that molten wax up into it, and that's what you see that's burning. Okay, and this has to be gotten rid of so that it doesn't draw any of the acid up into it, up into the rest of the wire or cable. In this case, cable. Okay, here's the reason, main reason why when you dip this into the acid, you're only going to dip it up to 3/4 the way of the length here, because it's obvious I'm not going to be able to get this clipped all the way inside here. Just can't reach it. So if you don't expose the this, you know, core to the acid, you won't be putting any acid in the rest of this, which it doesn't take a rocket scientist to realize that the acid, if it's in here, is eventually going to weaken the cable by way of eating away the material. Okay, I'd hate to be the guy who made that mistake and be responsible for somebody being killed when the cable lets loose. You want to try and bend this core as far away from the center line as you possibly can, so that you can get as much of this core removed as you possibly can. Come on, you. All right. This material is tough, let me tell you. Boy, the core of the core is a lot, seems like it's got a lot more tensile strength than the rest of it. Almost. There we go. Okay, now this guy, I've got to get these pieces that I pushed down pushed back up. See, it doesn't, you know, a person can see right away that if you get rid of the core, you're making a little bit of room inside this mass right here, and that'll come in. There'll be an advantage to that when you try and put this inside the socket. All right. Now this job is part of this job is to get the core back into position to make your job a little bit easier. I was gonna, for a second there, I thought I saw some blood. I was gonna try and limit this to just a 30-minute video, but it just doesn't seem like it's possible. Anything I ever do is more than 30 minutes. Okay, I'm going to get a pair of needle nose. I'll be right back. Come on, needle nose, where are you? Alright, sorry to make you wait, but I had to grab something that would do a better job at straightening these wires out. Okay, so basically got the core out of the way, and we've got the core remnants back more or less in the center. See if I can squeeze these a little better. That's pretty good. Now, the next thing is you've got to broom these out. And easiest way to do it is just to grip the end of it and just make sure everybody is unwrapped. Okay, that's straight. See, the more you unwrap them, make sure they're unwrapped, the more you'll be assuring that the zinc will have room to brush into here, or rather to pour into here. In addition, you got to have these all broomed out so that the degreaser and the acid can reach where they need to reach. Now the degreaser, you don't have to worry about it getting into here. Okay, it's not going to act as an acid and tear up this material. You have to make certain that there's no grease from this point up to that, so that these will be clean enough for that zinc to meld with, or to bond with. Okay, that's the only thing that ensures that this is as strong as it's supposed to be, is if you make sure that it all bonds like it should. Okay. Now you continue to do this all the way around, all right, until all of these are spread out, broomed out. Okay, and I've shown you. Well, I'll finish this one before I finish this. The rest of it off camera, because it's not very entertaining. It's just basic drudgery. Doesn't take very long for this part, as long as you get the right tools and you make certain everybody is all spread out. Like this guy is being a bum. He doesn't want to broom. All right, now you go down as far as you can in here, find the places that didn't broom out on you, and spread them out with something like a screwdriver. Be careful handling these, because more than a few times I wasn't paying attention to what I was supposed to be doing, and I stuck myself with it. Like for instance, these are one size. You have some tiny little ones in here about the size of a hypodermic needle that can stick you even easier. Alright, so they're all untied or untwisted, except for you. Yeah, you didn't untwist. You didn't broom out on me good enough. Alright, that's better. There's your basic brooming out. Okay, this is done. The other end is going to be done the exact same way. Okay, so the next time I come on, I'll be degreasing it, acid treating it, and then the hard part comes, that we got to try and bring these all back together to where they'll come down into these little tiny holes. Okay, and that basically is the hard part. Let me wipe my hands a little bit, because see, there's a lot of oil in here, oil grease, And if you don't already know, the reason why is because when you're using this cable, you know, it's going to be moved back and forth, and these will all be rubbing back and forth when you move them. You don't want the friction to build up to the point where bits and pieces of these cable bits are rubbed away, and thereby you're making this a weaker cable. Okay, that's why they got all this grease on here. You got to get it off to get to be able to acid treat it, and you got to acid treat it to make sure that the zinc is going to bond with the metal. Okay, so next time I come on, you'll be seeing that. All right, I'll see you next time. While you were off, I went and got a piece of actual tubing. This didn't allow for getting close in here, and I'll show you what I mean. You just open this up just enough for a piece of tubing to get on one of the wrappings. You get it as far down to the base where this is, and then while you're holding it close to the base, holding it hard, much easier than trying to use that piece of brass. Make it long enough to where you've got some mechanical advantage, enough for your hand to be on it. You don't need it this long, but just enough to where you can get your hand in it. The closer to the base where the seizing wire, and in this case the seizing wire and the hose clamp is, the more room you can make for getting rid of the core, cutting out the core down here. The more room you have for cutting out the core, the closer to the base you can get it, and the less messing around you're going to have to do. Ta-da! Now, there's good news and bad news when it comes to bending these all down. The good news is you can get to this core easier. The bad news is you've just put tension on these portions here, and you're going to have to fight to push them back up that much more. But I'm looking to getting rid of this much better than worrying about that, because I can always force these back up. This a little bit harder to get out. Okay, so the job is not done yet, obviously, but I'm going to try and feed you these in bits so that, well, you can take notes or you can practice these on your own. Plus, it's not going to be like a 7-hour gosh darn video, which would take me a week to upload, I'm sure. All right, so to those of you who've done this before, I'm sorry for bringing it up and bringing your nightmares back. But I'm also, well, it's nice to remember how to do this. If you ever had to you know, show off to your boss that you can do it, okay? To all of you out there, especially the ex-Navy who knows what this phrase means, Liberty Call.